When people hear the phrase new dojo supercomputer, they think it's just about more power, more chips, more racks, more cooling, more noise. But that misses the point. Raw power is easy to admire and easy to misunderstand. What actually matters is whether a machine is designed for the specific problem you're trying to solve. If your goal is real-world AI trained on massive amounts of video, motion, decisions, edge cases, and physical reality, then a general-purpose approach eventually hits a wall. That's where a system like Dojo becomes important. The core idea is simple. If you want machines to understand the real world, you need enormous amounts of training compute, and you need that compute to be optimized for the kind of data the real world actually produces. Roads are not spreadsheets. Cities are not clean benchmark tests. Reality is messy, fast, unpredictable, and full of weird exceptions. 1 second everything is normal, and the next second you have a cyclist emerging from shadow, rain distorting vision, glare on a windshield, construction cones in the wrong lane, and human behavior that makes no sense until it suddenly does. If you want AI to deal with that, you need a training system built for reality, not just theory. That's why the idea behind Dojo matters so much. It's not just a supercomputer in the traditional sense. It's an AI training machine built around the assumption that video, temporal context, and real-world perception are the path to solving autonomy. That changes the architecture. That changes the data pipeline. That changes how you think about scaling. And when you change all of that, you are not merely building a faster machine. You are building a machine that can learn from the world with increasing efficiency. A lot of people still underestimate how difficult real-world AI really is. They imagine that once a model performs well in a demo, the problem is nearly solved. It isn't. A demo is not reality. The difference between something that looks smart and something that is robust at scale is enormous. Real intelligence in the physical world is not about one perfect moment. It is about millions of imperfect moments. It is about handling the rare event, the strange behavior, the low probability failure mode, the scenario nobody thought mattered until it suddenly mattered a lot. Training for that requires a different level of compute intensity, and that is exactly where a purpose-built system like Dojo enters the conversation. The reason custom AI compute is so powerful is that it allows you to stop paying the tax of mismatch. Every time you use a system that was not designed for your workload, you lose efficiency somewhere. You lose it in bandwidth, you lose it in latency, you lose it in power, you lose it in cost, you lose it in how fast you can move from raw data to trained intelligence. When you build from the silicon upward with the workload in mind, you can remove layers of waste that people have accepted for years as normal. And once you remove enough waste, the difference becomes strategic, not incremental. This is the part a lot of people miss. AI progress is not just about smarter models. It is about the speed of the feedback loop. How quickly can you collect data, label it, train on it, test it, discover failure, retrain, and improve again? That loop is everything. If your loop is slow, your intelligence evolves slowly. If your loop is fast, your system compounds improvement. So when I talk about a new Dojo supercomputer, what I'm really talking about is compression of the learning cycle. I'm talking about turning AI development into a higher velocity engine. And once that engine starts accelerating, the implications go far beyond one product or one category. Yes, people naturally think about self-driving first because that is one of the hardest real-world AI problems ever attempted at scale. But the deeper truth is that the same training philosophy applies to robotics, manufacturing, intelligence, motion planning, and any system that has to perceive and act in the physical world. The real breakthrough is not that one machine becomes better. The breakthrough is that the infrastructure for training embodied intelligence becomes dramatically stronger. Now, let's be honest. Building a custom supercomputer is insanely difficult. It is not glamorous in the way people imagine. It's heat, power delivery, packaging, interconnects, software stacks, compiler work, failure analysis, yield issues, scheduling efficiency, memory constraints, and 1,000 engineering problems competing for attention at the same time. There is no magic in it. There is just disciplined engineering at a brutal scale. That's why so few organizations can even attempt it seriously. And that's also why, when it works, the advantage can be massive. What makes this especially important is that the AI race is increasingly becoming a compute race. Talent matters, algorithms matter, data matters, but if you cannot train fast enough at sufficient scale on the right architecture, your ambitions eventually collide with physics and economics. A lot of people talk about changing the world with AI, but the world does not change because of talk. It changes when you can actually afford to train the systems required to make that vision real. That is where supercomputing stops being a technical footnote and becomes the center of the story. And I think this is where the conversation gets really interesting, because the new Dojo supercomputer is not just about keeping up, it's about redefining what enough compute even means. Every generation of advanced AI makes the previous definition of scale look small. What seemed excessive a few years ago now looks necessary. What seems ambitious now may soon look conservative. That's the nature of exponential technology. The bar keeps moving. If you want to stay in front of that curve, you cannot think linearly. You have to build for the world that's coming, not the world that's already here. There's also a strategic lesson here for anyone building anything difficult. Vertical integration is not fashionable because it sounds cool. It matters when the existing supply chain cannot get you where you need to go. If the tools available to you are good enough, use them. But if the problem is important enough and the gap is large enough, then sometimes you have to build the tool itself. That's what ambitious engineering looks like. It looks irrational to people who only measure the present. It looks obvious in hindsight to people who benefit from the result. If you care about the future of AI, then do not just watch the apps. Watch the infrastructure. Watch the training systems. Watch the compute architecture. Watch the energy efficiency. Watch the data engines. The flashy part of intelligence is what the user sees. The decisive part is usually what the public barely notices at first. The visible breakthrough is often the shadow cast by an invisible machine doing impossibly hard work in the background. That's why this matters. That's why a Dojo supercomputer is more than a headline. I also think we need to stop viewing powerful compute as some abstract, distant concept. This is not about machines in a lab doing meaningless benchmarks. This is about whether AI can become useful in the physical world at scale. Can it navigate uncertainty? Can it react safely? Can it learn from vast streams of real experience? Can it help build systems that are more autonomous, more productive, more capable, and ultimately more helpful to civilization? Those are not trivial questions. Those are defining questions. And here's the uncomfortable truth. The future does not reward hesitation for very long. If you know the problem is hard, and you know the scale required is enormous, then the worst move is pretending small steps will somehow produce giant outcomes. Sometimes the only rational move is to go all in on the architecture of the future, build bigger, build smarter, build with first principles, build the machine behind the machine. Because once intelligence becomes a matter of infrastructure, whoever builds the strongest learning engine shapes what happens next. So when I talk about the new Dojo supercomputer revealed today, I'm not asking you to be impressed by a box of hardware. I'm asking you to recognize what it represents. It represents a refusal to accept off-the-shelf limits as permanent. It represents the belief that if reality is the training ground, then the compute stack should be designed for reality. It represents speed, iteration, ambition, and a very simple idea. If the mission is big enough, then the tools must become bigger too. That is the mindset that changes industries. Not comfort, not imitation, not endless commentary from the sidelines. Real change comes from people willing to engineer the bottleneck out of existence. And in AI, the bottleneck is increasingly training scale, data flow, and compute efficiency. Solve that, and you don't just improve a product, you unlock a platform for future intelligence. So here's my challenge to you. Don't just ask whether a supercomputer is powerful. Ask what it is powerful for. Ask what kind of future it makes possible. Ask who is designing the intelligence layer beneath the products everyone talks about. And ask yourself whether we are entering a time when the most important inventions are not the visible machines we use every day, but the invisible machines teaching those systems how to think. If that idea excites you, comment Dojo below. If you think custom AI compute will define the next decade, say so. And if you think the real revolution is only beginning, then stay locked in, because this is not the end of the story. This is the infrastructure phase. This is where the groundwork gets laid. And the people paying attention now will understand later why this moment mattered so much. The future of AI will not be won by slogans. It will be won by engineering. And engineering, when done right, is how impossible things slowly become inevitable.